Look into the night sky and witness an expansion where entire galaxies tear apart from one another at a rapidly increasing rate. Physicists identify the driver of this outward push as dark energy, an invisible phenomenon that counteracts the pull of gravity on a galactic scale. Mapping this acceleration required physicists to reconsider the mathematical foundations of the cosmos. Today, dark energy is a central pillar of modern cosmology, used to predict the ultimate expansion and eventual state of the universe. In late 2025, the astronomical community was forced to defend that pillar when a new research paper challenged the reality of cosmic acceleration. The researchers argued that the evidence for dark energy was weakening and that the expansion of the universe might actually be slowing down. Astronomers use Type I supernovae as cosmic distance markers. Because their peak brightness is consistent, they serve as a standardized measuring stick. The 2025 study claimed this measuring stick shrinks over time, distorting the math used to calculate distance. This distortion would create an illusion, making a universe that is actually slowing down appear to be speeding up. If true, these findings would invalidate 30 years of research and the discovery that earned the 2011 Nobel Prize in Physics. To verify the claim, a team from the University of Southampton launched a forensic audit to identify any potential errors in the 2025 analysis. The investigation was led by Dr. Phil Weissman and included Professor Adam Rees, one of the astrophysicists who first discovered that the universe was accelerating. Fellow original discoverers Brian Schmidt and Saul Perlmutter also contributed to the foundational research that the Southampton team was now stress testing. The Southampton team treated the 2025 data as an anomaly to be forensically audited, searching for the mechanical root of the discrepancy. The audit began by reviewing how the previous study accounted for the age of the stars involved in these explosions. This chart compares a galaxy's billion-year lifespan with a star's shorter life. The 2025 researchers incorrectly assumed these ages were identical. But young stars are born inside ancient galaxies constantly, giving the host and supernova entirely different birth dates. Conflating these two distinct ages skewed the entire historical timeline of the supernova data. This oversimplification of stellar age, not a change in the universe itself, was the primary cause of the warped distance measurements. The investigators also identified a second oversight regarding the environment surrounding each supernova. Modern cosmology requires a mathematical correction to account for the varying mass of different host galaxies to ensure measurements remain calibrated. The Southampton team noted that the 2025 study had omitted this standard mass correction from its equations. By ignoring these established variables, the challengers had introduced their own errors into the dataset. After identifying these flaws, the Southampton team recalibrated the entire dataset. When ages were properly separated and host mass accounted for, the supposed data anomaly disappeared. The corrected data confirms the universe's expansion is accelerating exactly as current cosmological models predict. This result affirms that the 2011 Nobel discovery remains a robust description of our universe. The controversy highlights the necessity of Professor Rees's observation that extraordinary claims demand careful testing. Questioning accepted ideas serves as a primary engine for advancing scientific understanding. By answering this challenge, researchers were able to revisit their assumptions and further refine the tools used to measure the cosmos. Through peer review and reanalysis, the astronomical community isolated a methodological error from a cosmic reality. While the measurement crisis has been resolved, the existential mystery that triggered it remains. We have proven that the universe is accelerating, but we still lack a definitive explanation for why it is happening. The specific nature of dark energy remains an unanswered question at the edge of physics. We continue to look out into empty space, seeking the origin of an invisible force that will determine the final state of the universe.